So here we are, Friday the 8th of May 2020. I'm not going to go over the homework and dictation and math mentals today. What we're going to do is we're going to focus on the science lessons from Mr. Detrix and the multi-bread and explain those to you really well. And even if you get those done today and get them sent in, that's really important that you do that. If you then have time and want to submit the homework, and some people already have for this week, I can mark that and give you dojo stars. If you want to do the mental maths for today, the Friday one, you can do that and submit that. But the science is going to be our focus today, just to make sure that we get that done. So if you go into Mr. Detrix's science lab, you can see that task 1 has been done, which is the coal one. You've watched the video. Task 2 was looking at different things under microscopes. And if you haven't done that one, you can see that he's actually put the images in this time. Week 2, you watched a video about energies, and these are the answers to your questions. And the task for this week is about fossil fuels. So there's a video there, and then some discussion questions that you can write up on a page and send me. And there's also another task about identifying the slides. Now for this week, week 3, so you need to do all those ones to catch up, but the week 3 one, he has the answers to those questions for this week. And if you keep reading down, this week we're going to focus on geothermal energy, which is energy from underground, and click on the video and he explains all that to you. And then there's some questions there for this week and another little task. Don't go on to week 4, just go up to week 3 and make sure you've done all those activities for this week. So the other part on there, and this is actually a mark that goes towards your science mark for your report card at the end of semester 1, is a mouldy bread experiment. And I'm just going to go over this with you to make sure that you understand it. So what we're going to look at over the next 5 weeks is the process that yeast and water and flour has, what the reaction is that forms from that, and of course we make bread like that, and we're then going to investigate the mold that grows on bread. So if you read this little part here, it will explain to you basically what we are doing. And not this week, but next week you will be conducting your own mouldy bread experiment by having 3 slices of bread in sealed clip seal bags and observe those over a number of days. And then when you come back to school, you'll do a poster about your observations and your results. Now, of course, mold grows, it's a living thing, and if you get it on your hands or on other items, it will grow on that. So it is a bit of a safety risk. So you need to read this with a parent and get them to help you, or an adult. So if we then go into the lesson for this week, okay, there's a video here which talks to you about experiments. I'll just click it very quickly. You can actually blow it up and make it bigger. Now this is to get a bit of a discussion going about mouldy bread. So life on Earth, this is a biological science unit. How you plan and investigate and how you observe, what we need to know and what we do. You can just have a quick read of this. The safety risks, which was on the first page that I showed you, and what you actually do in experiments. And I'll just take that one back a bit. Yep, come on. And it has a little bit of a guide there about what you actually do in experiments. There's no sound, it's not read to you, you just have to go through and read it, and that was the one I wanted to show you. And of course it's make observation, research the topic, ask a testable question, turn the question into a hypothesis, which is an educated guess about it, make predictions, conduct the experiment, and record your results. So just have a quick look at that. Now these little boxes down here for this week are discussion boxes. So Mrs. Welsh has set this up so that you click on it and people can write their comments in there, what you think about, have you made bread with yeast, and water before? Have you seen the whole process of, so you mix the water and the yeast together. Some people put a bit of sugar in, and the flour, you cover it and you watch it grow and expand, and then you have to mold it again, because there's a reaction occurring between the yeast, the water and the sugars in the flour, which is creating carbon dioxide, which creates bubbles of air in the yeast, and that causes the bread to expand. So then you knead the dough again, get the air bubbles working through the bread, you put it under the plastic or the cloth again, and it keeps going through this process of growing. And then you cook it and it makes lovely, crunchy, crusty bread. So you can put any comments down there, you just put the subject in, your message, and you type it up and it goes on this board here. Okay, so that's part of this week. Okay, so lesson 2 then looks at the variables for the first experiment we're going to do. And for the first experiment, we're not doing the moldy bread experiment. We're looking at that reaction between the yeast, the water, the flour, and the sugars in the flour. So what you need to do is, first of all, have a great understanding of, when you're doing scientific experimentation, fair testing. And fair testing basically means, just going to pause this for a sec. Okay, so I was just pausing that for a sec, waiting for this to load, and of course you got that off Ed Studio from here. So fair testing, you've probably heard of that before. It just means that when you're conducting a test, all the variables have to be the same. So if you are looking, which we are for this experiment, of adding yeast and different temperatures of water to flour to see that reaction and see the dough rise, you want to be using the same amount of flour, the same amount of water, mixing it for the same amount of time. The only changing variable is going to be whether you use cold, warm or hot water. Okay, so they just explain this fair testing idea and what's actually happening with the microorganisms in the mold. They actually call it cows move softly. So if what that means is, if you change one thing in your experiment, your independent variable, your measure and observation of another thing, your dependent variable, has to be the same all the time. So the independent variable is the flour and the water and the yeast. You're measuring your observations, and the dependent variable is the temperature of the water that you're using, and you have to keep those variables all the same. The independent variable is the same for every experiment that you do, and you record those results. So have a read through that, and it explains it to you. Then what you need to do is download this document, which is your yeast investigation. Now what I've done is I've gone through and filled it out a little bit just to give you an idea of how to do it. So put your name up the top. So Sally has, well, there's a bit of an error there, but Sally has Sally likes to bake a nice loaf of bread for dinner. Her family is visiting from interstate and she wants to impress them because they think she can't cook. You're going to conduct an investigation to find what temperature of water is best suited when adding yeast to make a loaf of bread that will rise. So this bit here, this is what you're testing. Okay, so in the variable grid below, record 4 variables that will remain the same, and 1 variable that will change, and 1 variable that will be measured. So these are your independent variables that are going to stay the same, your dependent variable that's going to change, and what is going to be measured. So I have put in my answers to show you how to do this. So the things that are going to be the same all the time is going to be the bowls, the spoon, the yeast, and the water. You're going to use those variables over and over again in your 3 experiments. Now what you're doing is you are mixing those ingredients with hot water, warm water and cold water. So you are going to have 3 bowls. So you are going to show your observations once the flour has been added, the mixture needed, and then placed into the bowl. So you've mixed it all up. You've mixed the yeast and the flour and the water, cold water in one bowl, and you have it sitting there. Then you've mixed one up with warm water and you have it sitting there, and one with hot water. Now what I suggest to you is that you do all your cold water first, because you have to write your observations in straight away. 0 minutes for that one, 15 minutes again for that one, and then 30 minutes for that one. Then with your warm, I'd mix it up, have it all sitting there in the bowl. Warm water, what it looks like, again and again, and then with your hot. And if you've got all those three going at the one time, it's going to be very hard to manage. So even if you do your hot first, then your warm, then your cold. So you are writing in your observations. So first of all, when you do it with cold water, in that minute, do you notice anything, or is it just like claggy flour sitting in the bowl? After 15 minutes, do you notice, and make sure you put a cloth or Glad wrap over the top, after 15 minutes, has it risen a little bit, but it's still claggy in the bowl? After 30 minutes, has it really risen a lot? I don't know, write that down. Or not much rise in the dough from sitting in the bowl. If you're mixing it with warm water, and my prediction would be that you're going to see more of a reaction, after 15 minutes, is the dough starting to rise up to the level sides of the bowl? Write down your observations in bullet point, and with hot water, they're going to be different again. And what you could even do is after 30 minutes for each one, take a photo of it and stick it in your document. I've just put one down here to show you that in this experiment, they've done it over 4 different observations, and they've got the bowls sitting next to each other on the bench, and they've actually put labels on the bowls. So there's just a little idea that you can do. So going back up to filling this out, so we're going to complete your investigation question. Remember that process was coming up with a question. So what happens to flour when you add yeast? And I'm going to take this bit out and write in there different temperatures of water. Okay, so that's your question, and we'll put a question mark in there as well. The next bit is complete your prediction. If I add yeast to water, then mix and add to plain flour, the flour will rise over a period of time. Now there's a bit more of our prediction in that, isn't it? If I add yeast to water, mix and add plain flour, we want to put in there that we're testing the idea of using the 3 different temperatures. So I add yeast to water, mix and add plain flour. We're going to take this bit out. Then add 3 different temperatures of water, cold, warm and hot. The yeast, the dough, this will affect the dough rising in the bowl, because yeast converts sugar and starch from the sugar and flour in the bread mix into carbon dioxide and ethanol, and this reaction is affected by the temperature of the water added to the flour. Okay, the carbon dioxide gas makes the dough rise, and the dough will rise faster in warmer conditions. So I've seen some cases where people have made bread and they've mixed up the dough and the water and the yeast, and they've covered it, and they've actually left that mixture next to the oven or on top of the oven or next to a fireplace just to get that reaction happening a bit faster. So that's a bit of background knowledge I have, and I bet you've seen someone make dough either on telly at home as well. So you've got your own prior knowledge to that, which will help your prediction. So your method is going to be to pour water in a glass, use hot, warm and cold in 3 separate bowls, and record your observations. You add a packet of yeast, add sugar. You don't have to because there's sugar in the flour, so I'm going to take that one out, and observe as the yeast mixture will start to double in size as it begins to proof or grow. So bakers call that process of the yeast reacting with the flour and the water and releasing carbon dioxide as proofing. And here's your observation table, and that's all you need to do. So this part needs to be done this week. You can do it over the weekend if you want. or take the day to get those different science experiments done. Next week what you are going to do, and I'm going to give you a bit of a cheeky look at that, is you're actually going to do the mouldy bread one. And that is week 4 lesson. So what you're going to do for that one is you're actually going to be placing 3 different breads into bags and leaving them in different conditions and recording it. And at the end of all of this, you will be doing up a poster in class of that. So that's a bit of an example of what you do. You draw up a grid, and on one day you put one in the fridge and one on the bench, and you watch the mould grow. So what I have got here very quickly, and I'll probably should show you this next week, is just a bit of a time-lapse video of mould growing on a tomato, and I'll just quickly show you that now. So this would be over a number of days, and you could also see the biological reaction happening here as the mould grows of the gases being released in the tomato as well. Okay, so just thought I'd show you that as a bit of a thinker for next week about what mould looks like. So that's it. If you still want to go ahead and do your homework and your maths mentals for Friday, you can do that and send it in, but priority is to get those science questions answered, because you will need them for the report card. Also next week we've got design technology going up, and you've got copies of those in the workbooks that you've taken home. The design technology, if you've done it already, also has a activity sheet, and I'll be putting this up on Edge Studio over the weekend so you can have a look at it. And there's a few people that have done this already in my class, and if you've already filled out the student booklet, which looks like this, and design your toy, that's fine. You don't have to do it again unless you want to. But the other thing that will be attached to that for everyone, sorry, this is very slow, for everyone to do is a little worksheet which has lots of YouTube places that you can go to look at toys, and it's not only toys though, it's lots of other things you can design using the 4 energies. And I would like you to have a look at this even if you've made your toy and finished the design technology, because it will explain to you, go away, it will explain to you about these energies: wind, electric, chemical and kinetic. So as you go through this PowerPoint, so the task was to build a toy, a fan, a lighted object or an alarm suitable for a particular need using electric, wind, chemical or kinetic energy. And these should be in your booklet now, and I'll put them up on Edge Studio to have a look as well. So it explains all that. It shows the different forms of energy that we have on our planet, and there's a YouTube there that explains it. Then there's a little energy conversion activity for you to do with an example. It goes into more detail about what energy conversion is. So you can take a chemical reaction from plants in a biodegradable process and use that as fuel. You can take light energy from the sun, which helps to grow plants. So that really explains that, and that's an important concept to understand. And there's YouTubes that you can click on that further explains that. Then there is a page with some YouTubes that talks about potential and kinetic energy and gives examples of those. And then there are loads of toys and examples of things you can make, and YouTubes that you can go to show you how to make them. And at the back there's more activities if you want to do some extension. So I'll put those up this weekend. You can start doing those if you want, but most importantly, please get those science activities done, because each week there's another experiment that you need to get in. And just to finish up very quickly, don't forget, if you are looking for additional work, there's the Fast Finisher sheet. You've always got your homework booklets that you can do as well. There's your Fast Finisher one. And you've got your Mathletics website, which I always encourage you to go on and complete. There's activities that are sent there to improve your skills, and epic reading and reading eggs. So have a great weekend, and I will put up some more lessons next week.